Okay, so properties of exponents. What is anything to the 0 power? 1. Everything to the 0 power becomes a 1. Come in. Alright, what does a negative exponent do?
Flips it to the bottom.
Flips it to the bottom. So that makes it 1 over a to the x. Alright, if you have things being divided, what does that subtract? You subtract, well, sorry, if your exponent is a division.
It's
A root.
It's a root.
Oh.
Which one goes outside?
The cube.
Okay. Alright, so it would be the p root, or the cube root of a to the p. And it doesn't matter if this p is under the radical or outside. It can actually be either. It won't matter. If things are multiplied and the base is written each time, what do you do with your exponents? If they are divided, so a to the x over a to the y, what do you do with your exponents? Power to a power. And if you have a single term on the inside and an exponent on the outside. Now that only works if it's one term, so no addition or subtraction on the inside. Alright. So far so good?
Exponentials aren't the E, right?
That's a type of exponential. Alright, so let's just practice using some properties of exponents here. So on the first one, x to the 4th times 3x squared to the 3rd. What would we have to do first? Yes. If we look, we have a power to a power, so we have to start out there. So we have x to the 4th. This becomes a 3 to the 3rd, x to the 6th. What is 3 to the 3rd? What? Oh. I don't have. Okay, and then we can multiply in any order. So if we combine those x's, what do you do with their exponents? So 27x to the 10. Alright, B. Where would we begin? Okay. These x's are multiplied so we can add their exponents. So 2n plus 3n minus 1 would be 5n minus 1. If we are dividing with those x's, what do we have to do with our exponents? Subtract. Now we have to be careful. We're subtracting the whole thing. So I have 5n minus 1 minus this n plus 2. So what would we have to do with that minus? So we get x, 5n plus negative n would be 4n. Negative 1 minus 2, negative. So x to the 4n minus. Why don't you guys try a couple? So see if you can simplify both of those. We are going to evaluate that without a calculator. What does it mean? What is the cube root of 8? And 2 to the 4th? So I have a 5. What is x to the 0? Okay. This would be 3 to the negative third, x to the negative 6. Here we would have 5 squared x to the 8. You guys okay with me there? So I distributed my exponents. Anything, well, okay. Where do you want to go?
I want to combine first.
You want to combine first? So you can take things to the bottom, you can combine first. Either one works. If you take 5 times 5 squared, that's 5 to the third, or 125. Okay, with my x's, x to the negative 6 and x to the positive 8. Okay, 3 to the negative third. I don't have any other 3's, but it's a negative, so where does it go? And 3 to the third is
27.
Can we handle those?
So you can't, when it's negative, you can't just make it negative. So,
Right, it goes down to the bottom.
so arbitrary.
Alright, let's try some more. Four to the negative third over 2 to the negative 8. Now this one is a little bit different. I can't just divide the 4 and the 2 because they're different bases. We can go ahead, you guys want to flip and get rid of some of our negatives. So 4 to the negative third would put a 4 to the positive third on the bottom.
2 squared.
The 2 would go to the top. Okay. So you said change your 4 to 2 squared. Do we all agree that 2 squared is the same as 4? And how does this help me?
Because you can find a base.
So the top is 2 to the 8. On the bottom, this is 2 to the 6. When we divide, what do we do with our exponents?
Subtract. Yeah, use 4.
So you have to get that common base before you can use those exponents. Alright, this one is fun. Yes, let's change those radicals into fractions. So, if I work on the outside, okay, this whole thing was under a square root. A square root is what power? Then underneath I had an x. Then I had a second square root. So that xy would be to the half power. On the bottom, this whole thing was to the fourth root, which is the 1/4 power. And now it's more like our other problems. Let's start on the inside. So I would have to distribute this 1/2, so the x, that's x to the 1/2, y to the 1/2. What do I do with my 1/4? X to the 3/4, y to the 5/4. So you can either combine or distribute first. I heard distribute, so that's x to the 1/2, x to the 1/4, y to the 1/4. So you want to combine our x's on the top, what would you do with those exponents? Half. So 1/2 plus 1/4. Okay, what happens? X cancels, same thing on top and bottom. Okay, the y's we divide, so subtract exponents. Where do we have more? So 5/4 minus 1/4 is 4/4 or just 1. So we get 1/1. Alright. Any questions about these exponents? I want to talk a little bit about the graph of an exponential. Not necessarily going to be something that we spend a ton of time doing, but good to maybe touch on as it could come up at some point. When we graph exponentials, like 2 to the x power, 3 to the x, we always kind of made a t-chart. Do you remember what 3 numbers we always plugged in for our x?
0 or negative.
So if we're going to graph an exponential, we have to have a parent function. And to get that, we need a minimum of 3 exact points. And we use -1, 0, and 1 for that. And then we just kind of made our t-chart from there. So if I asked you to try, do you guys think you remember?
Yeah.
Maybe. Let's do, I'm gonna flip my order. Okay. I want you guys to see if you can graph that. You need a parent function and then your transformation. So take a second, see what you remember, what you can come up with. So what's the parent function?
-1, 1, 0, -1, and 1, 1.
So you're graphing 3 to the x, right? That's the exponential
Oh.
piece. And so for your parent function, yeah, thanks for coming in. 3 to the -1 would be 1/3. 3 to the 0 is 1. 3 to the first is 3. So -1, 1/3. 0, 1, 1/3. This is my parent. Remember, exponentials have a horizontal asymptote at 0 because you'll never do 3 to a power and get 0 or a negative. And then my transformation, what's this one doing? That -2 would move it down 2. So we had a horizontal asymptote at 0, but because we shifted down, it came down to -2. Okay, so you have to graph your parent function and your transformation there. Parent function gives us our starting points. What is the domain of that final one? And that is every time. What is the range of this one? Okay. Let's do another one of these together. Y equals 3 minus 2 to the x. So another way of writing this, if you prefer, it's like a -2 to the x plus 3. What is the parent function? Well, it would just be the positive of it. The negative will be part of our transformations. So we'll graph our 2 to the x first. And then our -1, 0, and 1. 2 to the -1. 2 to the 0. 2 to the first. So -1, 1/2. 0, 1. 1, So the negative out in front will do what? So it's like making all your y's negative, so it flips it over to y. The plus 3 will move up 3. Alright, so I had a horizontal asymptote of 0. Since we went up 3, it will now be a positive 3. So I think I have a point. If I flip it, it comes down here, then up 3. I have a point, flip it, it goes down here, up 3. 1, 2, we go to 1, negative 2, up 3. What's our domain? Range?
Positive, to 2.
3. Do we kind of remember doing these? Always have a horizontal asymptote and increasing from there. All right. Let's talk about some domain problems. We've had some of these before. Alright, if you have a square root, what do we know about the thing under a square root? Okay. What would you do now? Mm-hmm. So this means 2 to the t is less than or equal to 1. Okay. That's a little trickier. Can you tell me what value of t would make it equal 1? 0. Anything to the 0 power is 1. So t would have to be? So 0 is what makes that equal to 1. We want it to be smaller than 1, so t has to be less than 0. Interval notation, that would be negative infinity to 0 with the bracket. B. If we have a fraction, what do we know? So e to the t minus 1 cannot be 0. So e to the t cannot be 1. Yeah. So t can't be 0. Since anything to the 0 power equals 1. So my domain is negative infinity to 0. Union 0 to infinity. Alright. That is technically undefined.
That car's asked that 2 years ago.
Probably. Okay, do you guys want me to stop or just power through? We have logs. I have like a definition and 3 examples.
If we finish it, do we get more work time?
Yeah.
Okay.
You want me to just teach today, and if we get done, then tomorrow will just be strictly a work day.
Yeah.
Okay. I'm gonna go to this slide. Okay, so properties of logs. Let's see what we remember. Log base A of x equals y. Remember we always
to the A equals X.
the base of the log is the base of your exponential. So a log is like telling you what your exponent was. How do we break it apart if we have the log of two things being added? We add each individual log. If they are divided, okay? If you have the log of something to a power, alright. The two types of logs we see typically, common log is written as log. What is the base of that? Natural log, we see that ln. What's the base of that? Okay, I'm going to do my examples slightly out of order. Because I'm not sure if I'll have enough time to do all of them, so I'm going to do a couple equation problems, and then if we need to, I'll do my graphing examples. That'll be done. Okay. Okay, if I asked you to evaluate log base 2 of 80 minus log base 2 of 5. If we don't use a calculator, we have to first condense these. So if two logs are subtracted, you can put them together by dividing the arguments. Now, if you understand what a log means, you might just be able to look at this and answer. This is like saying 2 to what power equals 16? 4. And so you could just write 4. If that's not obvious to you, you can say this is equal to x and use your definition. 2 to the x equals 16. And then can you see it? So some people can just look at it, some people need to write it out. You can even say, well, if I was trying to get a common base, 2 to the 4th equals 16, so x is 4. So the amount of work you show is just kind of up to you, what you need.
When we answer that question, is it just equal 4, or
Yep.
do we put x equals 4?
You don't have to put x.
Okay, just say equal 4 is fine.
Let's solve a couple more. We'll solve some equations. And this will be our last slide for today. On A, do I know when the natural log of x is equal to 5? What is the base of a natural log? So how would I write this in exponential form? That's my answer. X is just e to the 5th.
I thought you were gonna have us like calculate.
No, let's just leave it nice.
You got an issue with me?
Yes.
Alright.
Okay.
With logs, the argument always has to be a positive, but it's e to the 5th positive.
Sure, also.
So we're fine there. B. How would I rewrite this one? B to the third equals x squared minus
Do you
1.
want us to factor that?
What would we do to get x by itself?
Add one.
Or would we just give you guys?
And then we square root.
With square root, you would do?
But minus. So we're solving for x
Mhm.
and all of these.
Yep.
Okay.
C. Do I know 2 to what power equals 3? No, it's not a nice one.
Wouldn't that be cool?
So typically, I guess you had a couple options. You could write it with like a log base 2. But when we were solving these, if we wanted to use them on our calculator, we had to add a log to each side so we could use the common log when we did it. So remember, we would add a log on each side of the equation. And then properties of logs, what happens?
Logs cancel out. No, that's not right. You can combine them because they're legs.
The
Oh, the exponent.
exponent drops down.
You divide the log over.
Mm-hmm.
Oh, just add your 5.
And you could certainly put this in your calculator and get a decimal, but I'm just going to leave it like this.
Yeah, just simple.
Simple, yeah, basic. Final one of the day. Yeah. So it's the same idea, but a natural log would probably be nicer here. Because a natural log and an e have the same base. What happens then? Those cancel because log base e of e, that drops. So I can subtract over my 5 and divide by -3. You can certainly get a decimal